Okay, so let's talk about some special systems of equations that you'll need to know about. So I have here three equations, and I'm going to take the top two as a system of equations. Now look, I know I'm choosing an easy example here, but I have basically here two of the same line. So if I graph the first line and then I graph the second line, those two lines are exactly the same, right? So they share an infinite number of points. Whenever two lines share an infinite number of points, we call that system consistent and dependent. And it means there are an infinite number of solutions. If I looked at the second two equations as a system, those are going to have the same slope but pass through different points, like that. So those are going to be parallel. They never cross, and so there are no solutions. And we call a system that has no solutions inconsistent. Inconsistent system, parallel, no solution. Consistent dependent system, same line, infinite solutions. Now, I bring that up. When it's graphing, it's easy to see what's going on. When you're doing substitution or elimination, though, it's important to understand what will happen if you have an inconsistent system or a consistent and dependent system. So I'd like you to look at these two equations. If I decided to do elimination here, for instance, I would subtract the bottom equation from the top one to make the x's go away. But when I did that, the x's would go away, the y's would go away, and the 7's would go away. And I'd have 0 equals 0. 0 does equal 0. True statement, right? Now, if I look at the inconsistent system, and I were to do, say, elimination on this one, and subtract the two equations, the x's would go away, the y's would go away, and you'd be left with 7 minus 4, which is 3. 0 equals 3. Not true ever. So the idea is, if it's inconsistent and all the variables go away, you'll be left with a statement that's not true. If it's consistent and dependent, and all the variables will go away, and you'll be left with a statement that is true. So here's a statement of that. If when you solve a system of a substitution or elimination and all of the variables go away, one of two things has happened. If the remaining equation, meaning like the 0 equals 0, or 3 equals 3, or 6 equals 6, is true, the lines are the same, and therefore there are infinite solutions to the system, and that would be consistent and dependent. If the equation isn't true, like 0 equals 3 or 7 equals 12 or something like that, the lines are parallel, there is no solution to the system, and that is an inconsistent system.